Hello, this is our design project video. We're the Big Beautiful Beans. This is by Ian De La Fuente, Marco Karpman, and Owen Misak. This is our process flow diagram. We have whole grains, coffee beans that we put into the roaster, and then coffee beans shaft that comes out, plus the whole roasted coffee beans that also come out. We set the grinder to 22, and we put the whole roasted coffee beans into the grinder, and we get grinded coffee beans that also come out. On the side, we put cool water into a kettle and heat it to 94 degrees, and we get heated water that comes out. And then for the clever dripper, we put the coffee filter in, the grinded coffee beans, and the heated water, and we let it sit for 5 minutes. And then we get a coffee beverage that comes out, plus the spent moist coffee grounds, plus coffee filter. Our mass balances, so our roasting balance, our whole grain coffee beans amounts to 120 grams, and we get whole roasted beans 100 grams plus the chaff of 4 grams. Grinding coffee balance, the whole roasted beans is 20 grams, so we use 20 grams in this instance, and then we get ground coffee beans, of course, which is 20 grams as a result of the grinding. And then for the water balance, we use the cool water of 420 grams, and heating it up, we get hot water of 380 grams. And then for brewing balance, we put 20 grams of grounded coffee, plus the hot water of 380 grams, plus the coffee filter, and we get a coffee beverage of 335.7 grams and spent coffee grounds of 64.3 grams.
So for the coffee beans, we decided to stick with Ethiopia, just purely based on the collective agreement that it tasted better. Mm. For the settings of the roaster, we initially went with 7, but then changed to 8 around halfway, and then roasted that for about 9 minutes. 9 minutes, actually. And then the initial mass of the green beans was 120 grams, with the final mass being 100 grams due to the natural processes which cause us to lose a bit of mass along the way during the roasting process. Total energy usage can be divided between the roaster and the kettle, of which we use 0.15 kilowatts per hour for the roaster, and then 0.6 kilowatts per hour for the kettle. And we decided to go for a lighter roast in order to conserve more energy, while darker roast tastes, and because while darker roast tastes better, we realized that the trade-off for more energy usage was not worth it, considering the fact that lighter roast also tastes pretty good. Therefore, with this knowledge, we decided to turn down the power and then fan speed in order to use less energy. For the kettle, it was a similar story, and we set the kettle to a relatively low temperature of 94 degrees Celsius to minimize energy usage for the hot water in a similar fashion. And then here are our measurements for TDS and PE of the final brew design we used. TDS was at a 1.06, a little bit much on the thinner side. And then we had a PE of 17.7. And then with a brew ratio of 19, this places us in the sweet range of the coffee chasing chart with also a thin bias.
All right, for our sensory evaluations, our brew is on the thinner side for its texture while remaining relatively strong in flavor. It has a hint of bitterness that remains for a while on the palate after taking a sip. Despite the bitterness, the thinness of our brew allows for the strength not to be overpowering, as well as giving us a sweet note to the aftertaste. Our lower TDS value is definitely noticeable when drinking, and is reflected in the flavor profile with a smoother finish and a much less noticeable solids within the body. For how we could have improved our design by putting more time into our roast. We had to make a last minute swap from Costa Rica beans to Ethiopian beans because the lab ran out of Costa Rica beans. If we were to try and design another brew again, we would have to put more time and effort into getting a couple of combinations of bean choices and roast levels instead of putting all of our eggs into one basket. We could have improved our efficiency by better measuring out how much coffee our brews produce. We overshot the 925 milliliter mark in our competition, and this isn't too big of a deal because it ensured we had no penalty, but it's something in the future we could have worked on.